Okay. In the last class we have studied the models and ports. Models and ports. Okay. We have seen the model completely, the skeleton of that model, and also we have seen the body of that model also. Similarly, even we have seen the port list. What is the port? That's nothing but the input and output ports. We have the inputs and output. Inputs are nothing but they will give the feed the inputs toward the my digital system. That will process the inputs and will give the output. That's in the form of the result. That we call as the output. So that usually all the digital systems will have the input and output ports. Input and output ports. Those ports to be what the those ports we call is what the input ports. The port lists are here. What are those port lists? That the input, output, and also what the in-out. Input, output, and in-out. Input ports will give the only the what the inputs, and output ports will give the result. The in-out is used for the, it's a bidirectional one, will give the result which will be used toward the in-out port will be used for the as a input and even the for the output also. That is we have seen the connections rules also. How these input and output ports to be connected to my digital system. We have the some rules. That one we have seen in the last class. Today we will see that one we have the unconnected ports. Usually the ports usually will have always the ports are nothing but the input and output. These ports usually some ports will be used in the digital system, and even some digital, and these some ports will not be used for the further connections. Those to be called as what the unconnected ports. Those we call as what the unconnected ports. Unconnected ports andre sometimes the ports which will not at all useful for the any more connections. Those we call as the unconnected ports. Unconnected ports. How many? For example, in the full ladder. For example, in the full ladder, we have the input ports. How many input ports are there in the full ladder? 3 input ports are those. What are those? A, B, C in. Okay. And also we have the 2 output ports also. Which are those? Sum and carry. C out. Okay. C out. We have seen in the last class that's the A is useful, B is useful. This is the intermediate carry. That's why we call what the C in. Okay, we need to use that one. And also sum is necessary. Only when this is the C out is useful. Only when we have to mention only when there is a overflow is happening. That then only we will use the C out. Then there is not. This is not the compulsory connection we need to give in the programming. So we can also write the program related to this one is the model, and model name is what the full ladder with the 4 bits having the input and output ports here. I have to write what the first port is, what the model, end model. You should mention end model. Model bartakshana end model barbadbeko. Okay, this is the small letter only. Model also. Model name is what the full ladder of the 4 bit, and I have to mention here what the port list here. How many port lists are there? How many ports are there? Input ports are how many here? 3 are the input ports and 2 are the output ports here. Which are those? I have to write the first output ports and which are this is the C out is not at all useful in my any more further connections. It's for the unconnected ports we need to mention. It is not compulsory to always mention all the ports in the port list. If it is useful, then only you can use that. You can call that port in my programming. Then that is some C out is not at all useful. Don't write the C out. Next is what are those inputs? A, B, C in. Okay, these are the input ports. So that then you have to write the input ports. Which are those input ports? A, B, C in. And the output ports, which are those output ports? Sum and C out. C out is not we were using. because of the, this is what the unconnected ports, this is what the unconnected port condition. So we need not to mention that unconnected ports in my programming. Okay, then we need to write the some body about that one. This is what they call as what the unconnected ports. This is what the unconnected ports. Okay, unconnected ports. Take the heading as the unconnected ports. Take the heading as the unconnected ports. Verilog allows ports to remain unconnected. Verilog allows ports to remain unconnected. Okay, Verilog allows, because we are sometimes it is not said to call use always to the output ports, all the ports inside the my programming. Verilog allows ports to remain unconnected. Next point, certain output ports may be used only for debugging, maybe only for debugging, and if are not interested, to connect such ports to external environment, to external signals, then such ports can remain unconnected. Such ports remain unconnected by instantiating module as full adder with the instantiation name as the full A. You can give the full adder is the adder name, my module name. Full adder is the my module name, and the instantiation name can be given of your own. If it is not necessary to write the same name as the module name. It's the instantiating name. Okay, it's a choice name. You have to give the name of that particular module with the instantiation. Full adder with the full adder A, and we have the outputs. Which are those outputs? Sum and the carry out. But you have to write the only sum, carry, don't COT, don't write the COT here. Okay, just to copy this one. Okay, full adder 4, and the sum is the क्लास यार भय ಮೊದಲು ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡ್ರಿ, ಆಮೇಲೆ ಮುಗಿಸ್ರಿ. ಅಟೆಂಡ್ ಮಾಡಿ ತುಂಬ ಬುಕ್ ತೊಂಬ ಬುಕ್ಸ್ ತೊಂಬ ನಿಮ್ದು. ಬುಕ್ಸ್ ತೊಂಬ. ಯಾರ್ದು ಕ್ಲಾಸ್ ಇದು? ಎಕ್ಸ್ಪ್ಲೇನ್ ಬ್ಯಾಗ್ ತೊಗೊಂಡು ನಿಮ್ಮ ಬುಕ್ಸ್ ತೊಗೊಂಡು. Hey Mohan, come here. Mohan, hey Mohan. ಬರೋದೇ 2 ಕ್ಲಾಸ್, ಮತ್ತ ಅದ್ರಾಗ ಬೇರೆ ಇಲ್ಲಿ ಅಲ್ಲಿ ತಿರುಗ್ತೀರಿ. ಆ ಉಮಾದೇವಿ, ಐಶ್ವರ್ಯ ಎಲ್ಲಿದ್ರಿ ನೀವು? ಕ್ಲಾಸಿಗೆ ಬರಲ್ಲ? ಎಷ್ಟೊತ್ತ ಡೇ ಫುಲ್ ಮಾಡಿಸ್ತೇನಪ್ಪ ನೀ ACTC. ಅಲ್ಲ, ಡೇ ಫುಲ್ ಅದೇ ಮಾಡಿಸ್ತಿದ್ವಿ, ಏನೋ 1 hour ಮಾಡಿಸ್ಬೇಕು ಚಂತನ. ಅದೇ ಒಳಗೆ ಹೋಗಪ್ಪ, ಬಂದದ 2 ಕ್ಲಾಸ್, ಆಮೇಲೆ ಚೆಕ್ ಮಾಡ್ಕೊ ಹೋಗಿ 4 ಗಂಟೆ ಕ್ಲಾಸ್ ಮಾಡುದು. ACT ಆಕ್ಟಿವಿಟಿ ಡೇ ಫುಲ್ ಮಾಡಿಸ್ತೀನಿ ಹೇಳ್ಬಿಡ ಆ ಕಡೆ. ಅವ್ರು ಕಳ್ಸವ್ರು ಯಾರ್ಯಾರ ಅಲ್ಲಿ ಒಳಗ? ಏನೋ ಅರ್ಧ ಗಂಟೆ 1 ತಾಸಪ್ಪ, ಒಂದು ಡೇ ಫುಲ್ ಅದೇ. ಕ್ಲಾಸ್ ಬಿಟ್ಟು ಯಾಕೆ ತಿರುಗಾಡ್ತಿರ್ಲ? ಅದು ಇಡು, ಅಲ್ಲಿ ಒಳಗಿಡು, ಅಲ್ಲಿಡು, ಅಲ್ಲಿ ಕೊಡು, ಅಲ್ಲಿಡು, ಅಲ್ಲಿ ಆಮೇಲೆ ಕೊಡಕತ್ತೀನಿ, ಅಲ್ಲಿ ಒಳಗಡಿ ಒಳಗಡಿ. ರಾಚನಗೌಡ ಅವ್ರು ಕಳಿಸ್ತೀರ ಇಲ್ಲ ಯಾರ ಒಳಗ? ಚಂತನ ACT ಆಕ್ಟಿವಿಟಿ ಮಾಡಿಸ್ತಾನೆ, ಮುಂದೆ ಹತ್ತಿರ್ಲಿಲ್ಲ, ಅದೇ ಚಲೋ ಆಗ್ಯದ. ಅವ್ರಿಗೆ ಟೈಮ್ ಕೊಡೋದಿರ್ತದ. ಕ್ಲಾಸ್ ಬಿಟ್ಟು ಅದೇ ಮಾಡ್ತೀರಾ ನೀವು? ಚಂತನ ಒಂದ್ ಡೇ ಅದೇ ಮಾಡ್ತೀರಿ? ನಡಿ ಬಾ ಲೈವ, ಆಮೇಲೆ ಮಾಡ್ಕೊ ಕೂಡ್ರದು. ನಡಿ ಒಳಗ ಬಾ. ಐಶ್ವರ್ಯ ಎಲ್ಲಿ ಹೋಗ್ತೀರಿ? ಹೋಗ್ರಿ. ಅಲ್ಲ, ACT ಆಕ್ಟಿವಿಟಿ ಮುಂದಿನ ಸಂಜೆ ತಗ ಅದೇ ಮಾಡಿಸ್ತೀರಿ? ಬರ್ರಿ, ಅದ್ ಬಿಡ್ರಿ, ಆಮೇಲೆ ಮಾಡ್ರಿ.
ಏನಾಗ್ಯದ ಪ್ರಾಬ್ಲಮ್?
ಅಲ್ಲ, ಡೇ ಫುಲ್ ಅದೇ, ಬರೀ ಅದೇ ಚಂತನ ಅದೇ ಮಾಡ್ತೀವಿ. ಏನ್ ಅರ್ಧ ಗಂಟೆ ಮಾಡಿಸ್ ಪರವಾಗಿಲ್ಲ. ಹೆಂಗ ಪ್ರಾಬ್ಲಮ್ ಮುಂದಿನ ಸಂಜೆ ತಗೊಂಡು ಅದೇನು ಇರೋದೇ ಸ್ವಲ್ಪ ಕ್ಲಾಸ್ ಇರ್ತಾವ, ಅದ್ರಾಗ ಇರ್ತಾವ ಬೇರೆ. ಏನೋ ಅರ್ಧ ಗಂಟೆ 1 ತಾಸು ಮಾಡಿಸ್ ಪಟ್ನ. ಮೋಹನ್ ಕರೆದ್ರ ಕಿವಿ ಕೇಳೋದು ನಮ್ ಕಿತ್ತ ಹೆಚ್ಚಿಗೆ ತಾನೆ. ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಾನು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ತೀನಿ ನೋಡಿ, ಆಮೇಲೆ ಜಾಕಿರ್ನಿ ಅಷ್ಟೇ ಹೇಳೋದೇನು. ಓಕೆ, this is what the instantiation of my example here. Okay, the model name is here the full adder. You have to give the instantiation with the another name. It can be any small name, that's the. Then the output ports are here the sum. The unnecessary unconnected port is what? The COT is the unconnected port. This was the unconnected port. So this unconnected port is not necessary to mention always in the my module also. Okay, module while writing or while instantiation of that module, so that I can neglect this unconnected port in my while writing the program here. So that the full adder with the instantiation name, and also these are the port list. Which are those ports? Some COT and A, B, C are there. Okay, unconnected port is which one here? COT is the what? The unconnected port. So that one I have not written here. Unconnected port is not necessary to mention inside the module or instantiation. So this is the example for the unconnected ports in the instantiation. Just to copy this one, full adder with the instantiation name, sum. Okay, we have to give the space here. It's not connected. We are not using the unconnected port. A, B, C in. Just to copy this one. Okay, next is what? The Connecting ports by ordered list. Connecting ports by ordered list. Okay, we have the some ordered. Okay, we have the some ordered as they while giving the port list we have the ordered. First ಯಾವ್ದು ಬರೀಬೇಕು? ಫಸ್ಟ್ ಆರ್ಡರ್ ಪ್ರಕಾರ ಫಸ್ಟ್ ಔಟ್ಪುಟ್ ಪೋರ್ಟ್ಸ್ ಬರೀಬೇಕು, ಆಮೇಲೆ ಇನ್ಪುಟ್ ಪೋರ್ಟ್ಸ್ ಬರೀಬೇಕು. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ have the order, common order. But sometimes it is not necessary to always to write the orderly. Okay, that we call as the unordered or non-unordered ordered list also. First we'll see the connecting ports by ordered list. Okay, while connecting the example, while considering the example as the model top. This is what the model. This is what the model top. I did not mention here. Okay, if you just look at here, I did not mention any ports here. It means what the model top is not having any ports here. Model top is not having the any ports here. If it is having the ports, that is not necessary to mention the. That is, if it is not useful, those is to be not at all useful to write the programming in the programming. It's not necessary. Okay, and also we need to write the end model. End model. Okay. Just I am writing the one program here, that is the full adder purpose model full adder FA1. It is having the input and output ports as the sum, cout and A, B, C as the input and output ports list here. So that I am writing the program for the full adder here. I am writing the program for the full adder. Okay, it is having the 3 inputs and the 2 outputs. Just I mentioned the 2 outputs and the 3 inputs here for the full adder. So that I have to define the in the form of the input and output ports as the input ports are what are those? A, B, C in. Okay, these are the input ports. Output ports are there what the sum and cout. Sum and the cout here there. Sum and the cout. Okay, here the A, B, C in. How many are here? Okay, this is what the 4-bit here. 0, 1, 1, 1, 0, 1, 1, 1. Okay, this is what the A is here. This is what the B is here. So that I have to give the input in the form of what the array of list. Okay, list of. Okay, that's nothing but the I am mentioning the input ports here. The A and B are as the 1-bit only. If you want to send the 4-bit forms, I have to send in the form of what the vector form, so that I can mention here the input as the 3:0 because of the 4-bit 0, 1, 2, 3, 0, 1, 2, 3. Which are those? A and B are there. A, B is there. Okay, similarly even I can also write the input. Okay, even I can also write the inputs as the input here. What are those input? One more, that is the scene is the only one output, only one input is there. Huh? ಈಗ ಒಂದು ಕೆಲಸ ಮಾಡ್ರಿ, ನೀವು ಮಾತಾಡ್ರಿ, ನಾ ಕೇಳಿಸ್ಕೊಳ್ತೀನಿ. ಇಲ್ಲ ನಾಮ ಹೇಳತ್ತೀನಿ, ನೀವು ಸುಮ್ಮನೆ ಕೊಡ್ಬೇಕು. ಯಾವ್ದು ಮಾಡ್ತೀರಿ? ಹಾ, ನಾನು ಏನಾರು ಕಣ್ಣು ಅಂತ ಮಾತಾಡೋದು ಎಬ್ಬಿಸಿ ನಿಂದಿರ್ತೀನಿ ಕ್ಲಾಸ್ ಮುಗಿಯತಕ್ಕ. ಹೆಂಗ ಇಲ್ಲ ಎದ್ದು ಬರ್ಬೋರಿ, ನೀವು ಎದ್ದು ಬರ್ಬೋದು, ಎರಡ್ರ ಒಂದ್ ಮಾಡಿ. ಯಾವ್ದು ಮಾಡ್ತೀರಿ? ಎದ್ದು ಬರ್ಬೋತ್ರಿಯಾ? ಎದ್ದು ಬರ್ಬೋರಿ, ಅದು ಭಾಳ ಬೆಸ್ಟ್. ನನಗೆ ಯಾರೇ ಒಂದ್ ಸ್ವಲ್ಪ ಮಾತಾಡಿದ್ ಗೊತ್ತಾಯ್ತಂತ ನಾವು ಡೌಟ್ ಬಂತು, ನನ್ನ ಕಣ್ಣಲ್ಲ, ನಾನು ನಮ್ಮ ಹತ್ರ ಮಾತ್ರ ನೀವು ಬಿಡಲ್ಲ, ಹೊರ ಕಳಿಸ್ತೀನಿ ಒಂದು, ಇಲ್ಲ ಎದ್ದು ನಿಂದಿರ್ಸ್ತೀನಿ ಒಂದು. ಯಾವ್ದು ಮಾಡ್ತೀರಿ ಮಾಡಿ, ನಿಮ್ಮ ಇಷ್ಟ. ಏನಾದ್ರು ಗೊತ್ತಾಗಲಿ ಕ್ವಶನ್ಸ್ ಕೇಳ್ರಿ, ಪರವಾಗಿಲ್ಲ. ನನಗೆ ನಿಲ್ಲಿಸ್ರಿ, ಪರವಾಗಿಲ್ಲ. ನಮ್ಗೆ ಗೊತ್ತಾಗ್ತಿಲ್ಲ ಅಂತ ನಿಲ್ಲಿಸ್ಬೋದು, ಹಂಗೇನಿಲ್ಲ. ಸುಮ್ಮನೆ ಕೂತ್ಕೋಬೇಡ್ರಿ, ಅದೇ ನೆಸರಿ ಇಲ್ಲ, ಸುಮ್ಮನೆ ಕೂಡಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. ಬಟ್ ಥಿಂಗ್ ಇಸ್ ದಟ್ ನಾನು ಹೇಳುವಾಗ ನೀವು ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಮ್ಯೂಸಿಕ್ ಏನ್ ಕೊಡ್ತಿರಲ್ಲ, ಆ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಮ್ಯೂಸಿಕ್ ನಿಂದ ಸ್ವಲ್ಪ ಡಿಸ್ಟರ್ಬ್ ಆಗ್ತದ, ಅರ್ಥ ಮಾಡ್ಕೋರಿ. I hope you all understood that what I'm saying here. Okay. ಬಾಯಿ ಬಿಚ್ಚಿ ಸೌಂಡ್ ಮಾಡ್ರಿ, ಒಂದು ಮನಸ್ಸು ಇಟ್ಕೊಂಡು ಬಿಚ್ಚಿ ಸುಮ್ಮನೆ ಗುಂಗಿ ಅಂತ ಅನ್ಕೋತ ಕುಂದ್ರಬೇಡ್ರಿ. ನಾನೇನಾರ ಆ ಥರ ಇಂಡೈರೆಕ್ಟ್ಲಿ ಏನಾರು ಆಕ್ಟಿವಿಟೀಸ್ ಏನಾರು ಕಣ್ಣು ತಿಟ್ಕೋ ಅವ್ರಿಗೆ ಮಾತ್ರ ಬಿಡಲ್ಲ. ನಾನು ಇಲ್ಲಿ ನನ್ನ ಸಬ್ಜೆಕ್ಟ್ ಕಾಡದೇ ಇದ್ರು ಬೇರೆ ಸಬ್ಜೆಕ್ಟ್ ಕಾಡೇ ಕಾಡ್ತೀನಿ, ನೆನ್ಪಿಟ್ಕೋರಿ. ಹಾ, ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ಮತ್ತೆ ಇದಕ್ಕಿಂತ ಬಿಚ್ಚಿ ಏನ್ ಹೇಳ್ಬೇಕಪ್ಪ, ನಿಮ್ ಬಿಟ್ಟಿದ್ದು. ಓಕೆ, input ports and output port. Before that I should write the I should have to write the outputs also. Output, what are the output ports? Here the sum is the only one output port which is having the this is also having the 4 bits are there. Just to write do it connections addition will have the this is also 4-bit form. That's what I am writing the output as the sum as the 3:0 only. This is also 3:0 sum. And the COT is the only one, that is what they having the, this is not having the 4-bit form, that is this is also not having the 4-bit form, so that I can write the output, this is the output form, that is the COT as the output form. COT has the only single output form. And some model instances you can write the models. Okay, this model, this what is this one? Model FA1 has to be instantiated, or that is to be called in the what, the model top, with the help of what the calling the name as the what here the as the registers. Okay, whatever you have the inputs, those to be what considered as the output here. Whatever the outputs we have the, those to be considered as the inputs here. So that I am considering this as the output as the input with the help of what, the wire, calling the in the form of what, the wire. Yes sir, wire only, wire, that is to be what, the wires, which is the wire output is the what, the sum is the wire, that is to what, the 3:0. This is the what, the 3:0 sum form. And also wire sum, one more wire is there, that is nothing but the output, which is that COT is the one more, that one. Okay, and also inputs are what are the output form as the registers, as the register as the 3:0. This is also 3:0 and the A comma B. And also one more is that one input, that is the we call is the that one is to be written with the registers, that we have the Cin. Okay, Cin. Okay, some bodies there. This one we call the instantiation of this model FA1 inside the, we are calling inside what, the model top. But model top is not having the any input and output, but that is to be, we are instantiating our 4-bit full adder inside the model top. Okay, that one we call as the connecting ports by order list. As the first I have to mention the output, then the input. Here also we have to mention the output, that is we call as what, the wire and registers also. Okay, that's we call it the connecting ports by order list. Okay, this one I have written first one, and this I have written the second time, but you should have to write this first and second. Okay, just to copy this one, connecting ports by order list, while writing the connecting ports in the order list. Connecting ports are ordered list. Connecting ports in the order list is the most interactive, is most intuitive method is most intuitive method for beginners. Next point, signals to be connected must appear, in the form of instantiation, 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 in the same order, in the same order, in the same order, in the same order as the port in, 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 as the ports in the port list of model definition, as the port list of the model definition, as the port list of the model definition, of the port on of the model definition. Okay. Okay, this here the what we have the model definition. We have the sum and COT ABCN. Sum and the ABCN. What are those? Sum I should have to write the sum here, and the COT I should write the sum. That's nothing but the first I have to mention here the output ports here, output ports. Then the input ports I should have mentioned here the A comma B comma C in, A comma B, and this is what the C in. It means here the whatever the port list in the order, that one only I should write. First output baribeka, amel input baribeka. First output, that we call the connecting ports by order list. Okay, then you copy this figure first, this program. Then below this one you should have to write the instantiation program also. Just to copy these two programs. First, usually we'll write the first program, this one only. Within this block we call this model, model program in the with the instantiation name also, with the instantiation name. We are using what the inheritance property here. What we are doing? We are using the inheritance property. Just to copy that figure, those programs. First, side in model, full adder, and the wire as the raised to 0 as some end model, last in scene, FA1 sum CO2 A comma B comma C in. ಮಂಜುನಾಥ ಆರಾಮಿದ್ದಿಲ್ಲ? ಭಾಳ ಆರಾಮಿರ್ಬಾರ್ದು, ಭಾಳ ಆರಾಮಿರ್ಬಾರ್ದು, ಭಾಳ ಆರಾಮಿದ್ರು ಭಾಳ ಹೈರಾಣ. Okay, next is what the connecting ports by order. Now we have seen the connecting ports by ordered list, but now we will see the connecting ports by name, connecting ports by the name. I hope you all copied this one, so I will be erasing this one. This chapter itself is what the model and the ports. We study the only the architecture, what is the blocks of the module we are seeing, and also port. In this one, the port itself we are studying as the port names, port lists, and the optional parameters of port lists, and also port with the convention naming of the ports, and also we have seen the unconnected ports, and also we have seen the this one as the connecting ports by ordered list. Next is what the connecting ports with the order of for the name, by name. Okay, connecting ports by name, by the name. Okay, it's impractical. Actually, the one we have the port lists here. We will have the, okay, the ports name can be here A, B, C in the order. Okay, if you have the port list in the order, that is not necessary to have the always the port names in the as ordered by only, in the form of order only. It is not necessary to have always, but sometimes it is to be what the, if the ports names are correctly listed, those to be called here the programming also in the ordered form only. Sometimes because the ports name can be here the same name with the different arguments here, with different inputs there, though for the input forms are there. So that if I have the full ladder, okay, that's the instantiation name as the FA1, that is having the cout with the cout as the, this can be also be named with the capital letter also, small letter with the capital letter also, and the one with this one is to be what the sum, small letter sum, and this is to be also called as with the capital letter sum also. Okay, this is what the C agada yes bartade, C agada yes bartade. Next input outputs are next inputs inputs first A letter, small letter, and even we can also call this one with the big letter also, B with the big letter B, and also C in with the big letter C in also. Okay, this we call as the naming connecting ports by name order, connecting ports by the name order. Okay, take the connecting ports by name. Take the heading as the connecting ports by name. For large design, where modules have more than 50 ports, for large designs where the modules will have the more than 50 ports, remembering the order of 50 ports, for large designs where modules have more than 50 ports, remembering the order of the ports, in the module definition is impractical and error prone. If I have the more than 50 input ports or ports, whatever, that is impractical to mention in the port lists, with the port lists. Okay, next point. Verilog provides the capability to connect external signals. Verilog provides the capability to connect external signals to ports by the port names, rather than by order. In bracket, just to write the position. We can apply the next point. We can specify the port connections in any order. in any order as long as as long as as long as the port name in the model definition, the port name in the model definitions ಅಂದ್ರೇನು model name and the input port list, that will be called the model definition. Model definition currently matches the model definition correctly matches the external signal, correctly matches the external signal, correctly matches the external signal. For example, full adder, full with the underscore adder, fa1 dot cout. Okay, you should have to write the dot everywhere. Okay, comma cout, bracket cout, comma dot, you should have to mention the dot here. Okay, you should have to mention the dot here. Okay, wherever it is the variable, that's the port names are there. Okay, this should mention the dot ports also. Just to mention the dot, and also at the end this one is the semicolon, should have to write it here. This is what the example of the connecting ports by name. Next one is what the hierarchical names. This is the last concept to the what the second module, hierarchical name. Okay. Okay, today I'll send the questions. Start writing the assignment. First assignment should submit. Okay, I'll refer all the question papers. Don't worry, even you need not to necessary to open the question paper, see the questions and all. Okay, definitely I'll write all the questions which are related, frequently asked questions in the question bank order as the 15 questions from the first module and second module. Another 15 questions from the third module and fourth module. I'll be sending. Okay, 30 questions you should write in the assignment 1 and assignment 2. Next one is what the hierarchical header, hierarchical names. I have the notes here. This is one of the best notes. I referred even the books also. They are written this notes from the our reference book only, so that you can also refer these notes also. Okay, just to copy the whatever I written on the board. Okay, just to copy that complete. Okay, I hope you will copy now. Markodri. ಬರ್ಕೊಂಡ್ರೆ ಪ್ರದೀಪ್ ಬರ್ಕೊಲ್ಲ ಬೇರೆ ಬೇಕಿದ್ರೆ ಬರ್ಕೋ ಅರ್ಧ ಪೇಜ್ ನೀವು ಬರ್ಕೊಂಡಿಲ್ಲ ನಾಟ್ ರಿಟರ್ನ್ ಎನಿಥಿಂಗ್ ಬರ್ಕೋತೀರಿ ಉಳಿದು ಬರ್ಕೊಂಡ್ರಿ ಬರ್ಕೋತೀರಿ hierarchical names. Okay, while writing the program you should have to follow the models with the root with the and also what are the macros level, root level, leaf level, you should have to maintain that one. Okay, you should not write the first root bardu amel leaf baredu ಮಾಡಬಾರದು. First you should have to write the root, then macros and the leaf level. ಇದು ಏನಂತಾರ ಟಾಪ್ ಡೌನ್ ಅಪ್ರೋಚ್ ಅಂತಾರ. ಬಾಟಮ್ ಅಪ್ ಅಪ್ರೋಚ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತಾ ಫಸ್ಟ್ ಗೆ ಲೀಫ್ ಬರೆಯೋದು, ಆಮೇಲೆ ಮ್ಯಾಕ್ರೋಸ್, ಆಮೇಲೆ ಲಾಸ್ಟ್ ಗೆ ಬಾಟಮ್ ಲೆವೆಲ್ ಬರೆಯೋದು. ದಟ್ ವಿಲ್ ಕಾಲ್ಸ್ ದಿ ಹೈರಾರ್ಕಿಕಲ್. ಹೈರಾರ್ಕಿಕಲ್ ಅಂದ್ರೆ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಟು ಫಾಲೋ ದ ಸಮ್ ಆರ್ಡರ್ ಆಫ್ ರೈಟಿಂಗ್ ದ ಮ್ಯಾಕ್ರೋಸ್, ಸಮ್ ಲೀಫ್ ಅಂಡ್ ರೂಟ್ಸ್. ಯಾವ್ದಕ್ ರೂಟ್ ಅನ್ಬೇಕು, ಯಾವ್ದಕ್ ಲೀಫ್ ಅನ್ಬೇಕು, ಯಾವ್ದಕ್ ಮ್ಯಾಕ್ರೋ ಅನ್ಬೇಕು, you should have to identify while deciding, while writing the program with the particular digital system. Okay, if my digital system here the SR latch, that's what we call the SR latch, then you should have to identify that which is the root level, which is one is the macro level, which one is the leaf level. You should have to identify that one, then only start writing the program toward the particular digital system. On digital system naga first we should have to identify which one is the top level, macro level, leaf level anta ಕಂಡುಹಿಡಿಯಬೇಕು first. Okay, this is the hierarchical names. The Verilog supports the hierarchical design methodologies. Hierarchical design methodologies, Verilog, my Verilog HDL, what we are studying here, Verilog HDL or Verilog VHDL? Verilog HDL ಓದಕತ್ತೀವಿ, Verilog VHDL ಓದಲಿಕತ್ತೀವಿ ನಾವು ಇಲ್ಲಿ. Verilog HDL, okay, you should remember. Verilog Verilog HDL supports the hierarchical design methodologies, and also it supports the only the unit name. While writing the program, we should have the unit names for the particular for the particular order of that particular any of the digital system parts, blocks. Okay, then the board always start with the hierarchical names with the order of the with the dots. Always dots ದಿಂದ ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. ನೀವು ಎಲ್ಲೇ ಡಾಟ್ಸ್ ಬಂತಂದ್ರ ಅಲ್ಲಿ ನಿಮ್ದು ಏನದ hierarchical names are giving the hierarchical names also. The top level models always called with the root. Here we call the top level model is here the what is the top level model in this? This is what the top level model. This is what the root, that is the SR latch. We are putting this under the simulation ಮಾಡ್ತಿದ್ವಿ. Simulation itself, this is the root level model. Then in this simulation, that one is the what we call the N1 and N2, or what we call the macro level. That's the SR latch. This is what the simulation. We are putting this SR latch in the simulation. In this simulation only, what we are putting, this is the SR latch is what the macro level. This is what the macro level. Simulation is what the top level. This completely our SR latch we are putting in the simulation, that will be called the macro level. And this in this macro level only SR latch we are having the NAND N1 gate, NAND N2 gate. These two are the leaf level. You should have to identify. First idr sutta irtakantadu, if you are putting this complete my SR latch inside the simulation, simulation will not have any connections, okay, that will not have the any ports over there. That one we call as the top level. That we call as the top level. And this SR latch itself we call as what the macro level. This what the SR latch as the what the stimulus is the root level. This is the SR latch is what the M1 is the macro level. And the whatever the variables are there, S bar, R bar, Q bar, these are all what we call the variables. Variables are nothing but the this can have the another value also, not a constant. If it is not constant, then will not have the any other values. This variable can have the more than many inputs, okay, more than many inputs, that we call the variables. And also macro, this is the SR latch. This macro is created with the help of what the two NAND gates, which are those, first one is the first N1 gate, another one is the N2 gate. N2 gate is there. This one we call the NAND gates. This is leaf level. One more the input, okay. Four more signals are there. Which are those? Q bar, SR, S and R. These are the signals also. This we call the leaf level. Okay, this we call the leaf level. Always our hierarchical name starts always with the top level module toward the up to leaf level. Top level in the leaf level ಹೋಗೋದಕ್ಕೆ ಒಂದು hierarchical ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ top level module ಇಂದ apply ಮಾಡ್ತಾ ಇದೀವಿ. This is the one of the example for the hierarchical names. This is asked for the 6 marks. Okay, many times they ask for the 6 marks in the examination. Okay, this is all about the second module. Okay, today we completed the second module and even will start the third module also. Third module is very easy. I'll give the brief introduction about the all three modules. Okay, all three modules, don't worry. That will be helpful for us.